Hello and welcome to the analysis of the Hindu newspaper dated December 15th, 2022. In this video, we are going to talk about just one important newspaper article. Why one important newspaper article? Because we could only find just one important newspaper article which is very important, very significant for the civil services examination. We are going to understand this particular newspaper article in detail, but this doesn't discard the fact that other articles which are present in the Hindu newspaper weren't important. So here's a list of all the important newspaper articles which were present in the Hindu newspaper dated December 15th, 2022. So with this, let's now head to the first important and the last important newspaper article for the day. But before that, do consider subscribing to this channel to never miss an update from the bureaucratic way. And join us on Telegram to get all the important PDF significant for the civil services examination, right? So if this is very clear to you, let's now move ahead to the first important newspaper article. And this is going to be the last important newspaper article. We are going to discuss just one important newspaper article, right? So this one newspaper article talks about how gene therapy could cure cancer. And now with the help of CRISPR-Cas9, we have devised a technology so that we can treat the cancer, we can cure the cancer. Now this article becomes very significant for the GS paper 3, that is science and technology developments and their application and effects in everyday life, right? So let's deep dive into this particular newspaper article. So this article says that scientists in United Kingdom testing a new form of cancer therapy reported success in a teenaged girl Alicia with a form of cancer called T-cell acute lymphoblastic leukemia, right? So you need not to understand what this kind of disease is, but let me tell you in short detail. T-cell is what responsible for the T cell is part of a white blood cells. White blood cells fight against the cancer, fight against all the kind of impurities in your body. They are responsible for fighting against the diseases, and this is the basic function of the T cell, right? This is what you need to understand. Now, what happens in this form of this cancer? So in this form of blood cancer, the T cells, which are a class of white blood cells equipped to hunt and neutralize threats to the body, turn against the body and end up destroying healthy cells that normally help with the immunity. So what happens in this case? The healthy cells are being destroyed because of the cancer and the immunity is getting disturbed. If immunity is getting disturbed, you are more prone to diseases and you are more prone to death in some of the cases, right? So the disease is rapid and progressive and is usually treated by chemotherapy and radiation therapy. But in this case of Alicia, who is aged 13, this wasn't effective. She had already gone through the chemotherapy and radiation therapy. So we came up with what is known as base editing. We did base editing with her. So Alicia was first to receive experimental gene therapy that relied on a new technique called base editing. Now what is this base editing? You edit the bases of what? Person's genetic code. Now genetic code is present in DNA, right? Deoxyribose nucleic acid. In DNA, we have the genetic code. Genetic code is responsible for determining what kind of hairs you are going to have, what kind of body you are going to have, whether you are going to be short, fat, whatever it is. It is going to be decided by the genetic codes. It is going to be decided by the DNA. Now, a person's genetic code is several permutations of 4 bases. It has 4 bases which are known as A, G, C, T. A for adenine, G for guanine, C for cytosine and the T for thymine. And sequences of these bases akin to letters in the alphabet spell out genes that are instructions to produce the wide array of proteins necessary for the body's function. And this AGCT is responsible for what? To produce wide array of proteins. Now proteins are helpful for what? Building the muscles and all the other activities, and it is responsible for all the bodily functions, right? That is why AGCT is very significant, very important, and they form a sequence, right? So AGCT is basically an acronym for all of this: adenine, cytosine, guanine and thymine. And the DNA molecule consists of 2 strands, we all know that, and single stranded are what known as what? RNA. Now DNA is double stranded, wound around each other. Like in this particular case, we have seen this is known as what is known as DNA, right? And if you are more interested in the DNA or how it is formed or what is its structure, I will put a YouTube video. Now this YouTube video is just 47 seconds, so you can watch it and you can understand the complete structure of the DNA, right? So DNA molecules consist of two strands wound around each other, with each strand held together by bonds between the bases. Now the bonds between the bases are formed in such a way that adenine pairs with the thymine, that is A will bond with T, and C, that is cytosine, will bond with G, right? It will only bond with B. Now A will not bond with C and T will not bond with G, and the vice versa is true, right? Now the sequences of the bases in a protein of DNA molecule called a gene carries the instructions needed to assemble a protein. Now that we have understood what is AGCT or what is ACGT, we are going to understand what is this genetic code. Genetic code is basically the term we use for the way that the four bases of DNA, ACGTs, are strung together in a way that the cellular machinery, the ribosome, can read them and turn them into proteins. Different kinds of proteins are formed, and in this case, in the case of Alicia, what was happening? These proteins weren't forming and they were resulting in what? They were resulting in lack in immunity, and the lack in immunity would have certainly led to her death, right? This is how the coding is there, and this is how base editing works. Now in Alicia's case, her T cells, perhaps because of misarrangement in the sequences of the bases, had become cancerous, right? So the arrangement, which is in form of adenine pairs with thymine and a cytosine pairs with guanine, now this particular pairing is somehow defaulted in our case. Now we need to correct this particular misarrangement, right? So a way to correct this misarrangement would mean a healthier immune system, right? And if you are having a healthier immune system, then the immune system will fight against all the diseases, all the foreign diseases that are coming into your body. Now the foreign diseases are getting cured, or they are being fought by the immune system, then you are going to have a healthy body. So in the last 2 decades, the world of biomedical engineering has been enthused by a technique that allows genes to be altered and errors fixed. Now these particular genes can be altered. How? They can be altered with CRISPR-Cas9 system. Now inspired by how certain bacteria defend themselves against viruses, because in certain cases in bacteria what happens is that they alter their gene in order to protect themselves against the viruses. They somehow change their genetic sequence. That ACGT, they change it so that they can protect themselves against the viruses, and they do it by sniping out and storing pieces of their genes. That is, the CRISPR-Cas9 system consists of an enzyme that acts like a molecular scissors. So this CRISPR-Cas9 system is going to act like a molecular scissor. Now this particular scissor is going to cut some of the bonds that you are having, right? Some of the strands you are having. So it can be made to cut out a piece of DNA at a precise location, and a guide RNA can be used to insert a changed genetic code at the sites of incision. Now while there are few ways to affect such changes, the CRISPR-Cas9 system is believed to be the fast, most versatile system to affect such gene editing. So what you are doing? You are editing the genes. You are changing the sequence of the ACGT so that they fit according to what a normal human is having, right? So this is known as base editing. Now David Liu of the Broad Institute, Massachusetts, has improvised on the CRISPR-Cas9 to be able to directly change certain bases. Thus a C can be changed into a G and a T into an A. While still a nascent technology, base editing is reportedly more effective at treating blood disorders which are caused by so-called single point mutations, or when a change in a single base pair can cause terminal disease. If there is a change in a single base pair, then that can be altered, that can be edited in order to form the pair which is required, right? This is how the base editing works. Now, how did the base editing work for Alicia's therapy? So basically, the objective of the gene therapy in the case of T cell leukemia was to fix her immune system in a way that it stops making cancerous T cells. Now, first, healthy T cells which were present in her body were extracted from a donor. So now healthy T cells were extracted from a donor and put through a series of edits so as to suit her body, Alicia's body, right? T cells were extracted from a donor and they were edited in such a way that it represents the genes of Alicia. Now, the first base edit blocked the T cells targeting mechanism, so it would cease attacking Alicia's body, and the second removed a chemical marking called CD7 which is on the T cells, and the third prevented the cells being killed by a chemotherapy drug. And in this three-way process, we are finally able to edit the genes of Alicia. And finally, the T cells were programmed to destroy all the cells, cancerous or protective, with CD7 mark on it. And whatever the cells which had CD7 marking were destroyed through ways of various mechanisms, right? And after spending a month in remission, she was given a second donor transplant to regrow her immune system that would contain healthy T cells, right? So this is how the T cells were improved in her case. Now, how effective was this particular treatment? So 3 months after the treatment, her cancer seemed to resurface, but the most recent investigations suggest no signs of it according to the BBC. And now Alicia was one of the 10 people enrolled in a trial to receive the treatment, and it has been 1.5 years since she was first diagnosed with the disease, and whether the treatment has reliably and entirely fixed her immune system remains to be established at this particular point of time. But CRISPR-Cas9 system works very well. We know it. It edits the genes as to serve our own purpose. But this doesn't mean that CRISPR-Cas9 is not filled with all the positives. It has the negatives as well. For example, now you can design the designer babies, right? What are designer babies? Designer babies are essential what kind of attributes you want in a baby. These will be edited in such a way that you get the perfect child. Now, this perfect child will have certain kind of advantages over the imperfect childs which are present in the world right now, because every human is imperfect in their own ways, and that's the beauty of the humans, right? But if you make the perfect babies, then they are going to marvel, going to be marvelous at everything in life, and this brings about the questions regarding this particular technology. But in order to improve the immunity of the people, in order to do all of these things, all of the treatments, this particular technology becomes a very significant, right? So this is it regarding this particular newspaper article, and this is it for the day. Thank you from my side. Do like and share the video and subscribe to this channel. Have a good day. Bye.